Hi guys! Alright, we are going to solve a few more problems like finding our limiting reagent and also a bit of percent yield to give you some more practice problems. So here is your points for finding limiting reagents. Okay, so go ahead and copy that down and then we will get started. So we're back. This is the problem that we're going to use. So go ahead and copy down the information you need, write what is given, so that way you can figure out theoretical yield. When we give you masses, so let's say I give you 15 grams of water, how much oxygen is produced? That 15 grams is a theoretical yield, okay, theoretical number. And so you would solve for a theoretical yield of oxygen. And so that's what we're going to do right now. So we've written down some of our key points, like our equation, our Ty, theoretical yield of oxygen, and we want to find the theoretical yield of water. Then we're going to use our percent yield to solve for what our percent yield is. Sorry, and the AY is actual yield. So let's go ahead and solve for that. So write our given. Our given is 8.19 grams of oxygen, and this is going to need to be canceled out. So we want grams of oxygen, and so we're going to use the molar mass of oxygen. Which should be 32 grams, 16 times 2. And that way our grams will cancel out. Now we need our mole ratio. So looking back up at our equation, we need moles at the bottom of oxygen, and we want our units to be moles of water, eventually grams of water, but we've got to do moles of water first. So look at our ratio, we have 2 waters to 1 mole of oxygen. Okay? And we might not have enough space to do this last part, so we're going to come back down, and I'll move it over so you can see what I've done. So now we're going to come back down to here. Okay, and we'll just keep moving this up. Here we go. All right. And so then our last problem is going to need to cancel moles of water. Okay, so we want moles of water at the bottom. And so this is again a molar mass. And we know that 18 grams are in 1 mole of water. So that should cancel out our moles. Okay, now we can solve for it. So go ahead and plug this into your calculator. Let's see what we get. And I'll move my head. So now everything is here written out for us, what we need to do, and I have my calculator here. We have 8.19. You do not have to multiply it by 1, okay, because 1 is hopefully very simple. Multiply it by 2 and multiply it by 18. Then we press our equal sign. I put the ones at the bottom under parentheses, okay, which in this case would just be 32. And so let me make sure that my answer comes back. Divide that by, what did we say, 32, sorry. And the answer is 9.21 grams, okay? So we have 9.21 grams of water, okay? Now, we're going to take this and we're going to look at theoretical yield. So this is our theoretical yield of water, okay? 9.21 grams of water. Our actual yield, what we would actually get in a lab, of water, is 7.82 grams, again, of water. So what we want to do is put our actual yield over our theoretical yield, okay, and I'm going to bring these up so you can see them. I'm sorry. I do this in class too. Okay, so we have our theoretical yield of water, and then we have our actual yield of water. And then here you have actual yield over theoretical yield, multiply it by 100%, okay? And that should give us our answer. So let's plug that into the calculator and see what we get. So clear that answer, 7.82 divided by 9.21 equals 8.49, but we want to multiply that by 100, and our answer would be 84.91, or you could even round that to 85%. Okay, and so you would want to look for your answer on the test that is close to that. So this should look pretty familiar since we did it Wednesday in class, but I've changed our givens, okay? So we have 28.4 grams of aluminum and 18 grams of magnesium dioxide. So you have two things to find, the limiting reagent and how much aluminum oxide that we'll actually have, okay? When this reaction is completed, what will our product actually be? So let's do A first. And so remember our steps 1, 2, and 3 from earlier. Here they are in case you forget and you did not copy them. First we need to convert to moles, and we're going to use molar mass to do that. So let's do that real quick. I'll pause, catch up with us. Alright, so you can see that for part A, we have found our moles of aluminum and our moles of manganese dioxide. So now that we have our moles, we need to figure out how much we actually need, which is our step 2. Okay, so step 2, looking at this again, we need to use a mole ratio and then compare those mole ratios to see, do I have too much or do I have too little? If I have too much, that is my excess reagent, and I want to use the other one, the one that I don't have enough of, my limiting reagent. So let's go ahead and do that step. So you take the moles that you just found, and then you don't even have to do it to both. We will just for whichever one you chose while you're going along with us, and we are going to solve for the moles that we actually need. So I'll pause and do that for us. Alright, so now it's all completed for us. We take the moles that we have, the 1.05, and then we put it into the ratio. And so that ratio, remember, we get that from the formula at the beginning. So we had 3 MnO2s and 4 aluminums. Solve that and you get 0.79 moles of manganese dioxide. Then you take what we have, okay, and so this is have. I use a different color so it'll come out. Have. Okay, and so you take those things that you have, and we'll push them up just a little bit, and multiply them by reverse ratios. So now we're multiplying this by 4 and dividing by 3. We end up getting these two mole ratios. Okay, this is what we need if this is what I have. Okay, and the same thing down here at the bottom. If this is what I have of MnO2, this is what I need of aluminum. Okay, so now we need to compare these, and it's kind of crisscross. Okay, use Paul's crisscross applesauce. So if I have 0.21 moles and I need 0.79, I have a very small number and I need a big number. Okay, remember you can remove the decimal. Okay, if I need 79 and only have 21, I don't have enough. Now let's look at the other one. Again, hide the decimal. If I have 105 aluminums and I need 28, then I have a whole lot more than I actually need. Okay, so aluminum is our excess, where manganese dioxide is our limiting reagent. Now we move to step B. How much aluminum oxide will I actually have at the end? That is what we're trying to solve. So again, just as a reminder, I've written down that we found our limiting reagent. That's manganese oxide. And aluminum is the excess, okay? There's too much, we have too much aluminum, okay? So now we need to figure out how much aluminum. We must use our limiting reagent, okay? And so if you remember, we had 18 grams of manganese dioxide. And so that's what we're going to use to solve this problem. And we were asked to find aluminum dioxide, and we actually weren't told, but we're going to solve for grams, okay? And then we're going to solve for liters, just to cover that so you understand these problems better. So we'll move down again, rewrite this. 18 grams of manganese dioxide. Oops, sorry. We need to get rid of our grams. So we've already found our 87 grams of manganese dioxide, and that's in 1 mole. Okay, so grams will cancel out. Now I know that I eventually have to get to this aluminum oxide. So we need a mole ratio. And we need to look back at our equation. And here it is at the bottom. We have 3 manganese to 2 aluminum oxides. So we're going to 3 manganese oxides at the bottom. Okay, and that's moles, sorry, moles. And then here we have 2 aluminum oxides. And that will help us get to the grams and liters that we need. So we'll take that away. And then moles can cancel out. Now we need to find grams and get rid of moles. So in 1 mole of aluminum oxide, we know that there are 102 grams. And now we just need to plug this into our calculator, and then we're finished. So I'm going to move this up so we can see that together. Alright, so you have 18, oops, turn it on helps, 18 times 2 times 102, and equal sign. Divide all of that by 87, and this again is in parentheses, times 3, we can ignore the 1, finish the parentheses, and that equals 14, oh, there we go, 14.07 grams of Al2O3. Okay, and you can see that we rounded up to 7 because it's 2 decimal places. We like that. Alright, what if we need to find liters? That's our next step. So everything is exactly the same because we haven't changed what we need to find or what we're given. The only part that's different is this, okay? The last part. So we can go ahead and write that in. 18 grams, whoops, 18 grams manganese dioxide over 1 mole manganese dioxide. Put the molar mass. Same molar ratio, you have the 3 and the 2. And the only thing different is this last step. So we have the 1 mole of aluminum oxide, and instead of putting the molar mass, we want to find liters. Okay, so in 1 mole, no matter what compound we're dealing with, there is always 22.4 liters if that compound is a gas. Okay, and so we're saying at STP, this is a gas. Okay, plug it into your calculator. Alright, so that's 18 times 2 times 22.4 equal sign. Then we're going to divide that by the 87 times 3, and you get 3.09 liters of aluminum oxide. And that's it.